Hello, math humans. We're going to do 2.4b today. That is a B. Sorry, you can't tell that. It's more chain rule. Our objectives are love algebra. Algebra is probably the most entertaining part about calculus. So really what we're going to do is more of the chain rule. So let's just start with an example. We have a fairly short video today, lucky you. So y is going to equal 3x minus 1 over x squared plus 3 to the third. Oops, I lied, to the second. So what I notice, and I want to find the derivative, what I notice is I have a power, and I have the quotient rule, and I have a chain rule. So I'm going to rewrite this, and I'm going to write y is equal to 3x minus 1 to the second over x squared plus 3 to the second. And then I think that will be easier to manage. If I take the derivative, f prime of x, remember it's low d high minus high d low over low squared. And when I do my derivatives, I'm going to have chain rules, okay? If you need to, you can write that additional notation as you move through the problem. I just choose not to do that because I think it makes the problem a little bit more cumbersome. So here we go. It's low, x squared plus 3 squared times the derivative of the high. All of these guys are going to be multiplied together. 2 times 3x minus 1 to the first times the derivative of the inside. There's the chain. Low d high minus high, 3x minus 1 squared times the derivative of the low, 2x squared plus 3 to the first times the derivative of the inside, all over low, x squared plus 3 to the second squared. Ooh, that's a lot of math. And I will tell you before you start distributing, we're going to take out common terms, okay? Factoring is your favorite F word. I will clean this up a little bit just because I think it will help. So I have x squared plus 3 to the second. I have a 6. I'm going to put it right there. And then I have 3x minus 1. Right here, I have a minus 4x, and I'm going to have a 3x minus 1 squared and an x squared plus 3 to the first. Remember, don't ever expand the denominator, okay? So there's my cleaned up version a little bit. So I'm going to factor out, I have x squared plus 3's in both terms, and I have a 3x minus 1 in both terms. In the first one, it leaves a 6. That's a 6. And it leaves an x squared plus 3. This divided by this is 1. In the second one, I have a 4x. I have 1 3x minus 1, and I already have that. And then I'm going to have x squared plus 3 to the fourth. And you'll notice that one of those can cancel, so it leaves x squared plus 3 to the third. So now I'm going to clean this up. I'm going to have 3x minus 1. On the inside, I'm going to have 6x squared plus 18 minus 12x squared plus 4x. Okay? And then here's my denominator, x squared plus 3 to the third. Clean this up a little bit more. 3x minus 1. 6x squared minus 12x squared is a negative 6x squared, so I use those two, plus 4x plus 18, and then all over x squared plus 3 cubed. Now, I would not, under any circumstances, that's an x, distribute the numerator because that's going to take you too much time. At this point, I could evaluate the derivative at this point and be very successful. So remember that we need to simplify the derivative, especially if I had to take a second derivative, and that would be rude for this one. But I want to simplify my derivative to a point that I could manage evaluating the slope at a given point. All right, for our second example, example number 2, we're going to have y is equal to the cosine of 3x squared, and I want to know what is dy dx. Okay, and that's the derivative. Remember, we have lots of different types of notation to find the derivative. I will tell you that this is actually the cosine of 3x squared, but oftentimes they will leave that set of parentheses off. So you have to understand what's going on. Because they're a set of parentheses, that means then that this is actually the chain rule. So when I take my derivative, I'll write dy dx. The derivative of cosine is a negative sign. What starts inside stays inside times the derivative of the inside 6x. So then I would write this as a negative 6x sine, I guess I don't need that parentheses, of 3x squared. Okay? And then there we go. So it's actually not nearly as complicated as it looks. So we have one more example for us. It's going to be a longer example. So scoot it up and see if I can squish it in on this page. Example number 3 says find an equation of the tangent line, which means I have to find nt, which means I have to find a derivative to the graph of f of x is equal to 2 sine x plus the cosine, trig, 2x at the point pi, that's a pi, 1. Then determine all values of x from 0 to 2 pi where the graph of f has a horizontal tangent. All right, so anytime it says find an equation of the tangent line, that means you have to find the derivative, okay? So I'm just going to kind of combine my information. So this is 2 sine x plus the cosine of 2x. My derivative, okay, the derivative of sine is cosine. And then this is the chain rule because that's technically inside. The derivative of cosine is a negative sine of 2x times the derivative of the inside 2. And I'm going to clean this up to be 2 cosine x minus 2 sine of 2x. Okay? So there's my derivative, and I want to evaluate my derivative. This line means evaluate in calculus. And I'm just going to write the point at the bottom. So that means evaluate the derivative at this point. So f prime of pi is going to equal 2 times the cosine of pi minus 2 sine 2 pi. Okay, now I'm going to simplify. The cosine of pi is a negative 1, so this is a negative 2. The sine of 2 pi, remember 2 pi is right here. The coordinates are 1, 0. Sine is y, so this is a negative 2 times 0, so it's minus 2 times 0. This goes to 0, so my slope at pi is a negative 2. So now I want to write the equation of the tangent line. So y minus y1 is the slope of the tangent times x minus x1. So y minus 1 is equal to a negative 2 x minus pi, and I'm going to write y tangent is equal to a negative 2 times x minus pi plus 1. Okay, so that is the slope of the tangent line. So that was a lot of work to find the equation of the tangent line at the given point. So a couple of things to notice about my work. I rewrote the function. I wrote that I am working on the derivative. I showed that I'm going to evaluate the derivative at a point. I reported the slope of the derivative, and then I did my work for the equation. When you sit for an AP exam, you have to label your work as well as your solutions. So you want to make sure that the reader can follow what you're doing. Okay? All right. The second part of the problem said, determine all values of x where the graph has a horizontal tangent. So remember, if you think about, if I have a function, a horizontal tangent means the slope is going to equal 0. So what I'm going to do is I'm going to take my derivative, which was right here. So I'm going to take I'll write it here so we can see it. So it was 2 cosine x minus 2 sine of 2x, and I'm going to set that derivative equal to 0. And again, this is an important step for the reader to see, because if you're looking for a horizontal tangent, that means that you're setting the slope equal to 0. They need to see that step. So then I have 2 cosine x minus 2 sine of 2x is equal to 0. The sine of a double angle, if you will remember from trig, is, let me look and check and make sure I don't screw it up. It's 2 sine of x cosine of x. This would be one of the only identities that I would say that you need to remember. So this equation becomes 2 cosine x minus 4 sine of x cosine of x equals 0. I'm going to factor out the 2, and I get cosine x minus 2 sine x cosine x is 0. The 2 will go away. I'm going to factor out a cosine of x, and I'm going to get 1 minus 2 sine x equals 0. We love trig. Now these are my two baby equations, so I'm going to get the cosine of x is equal to 0, and the sine of x is equal to 1/2. So remember, cosine is 0 at x is equal to pi over 2 and 3 pi over 2. And then, yeah, trig, sine is 1/2. Sine is positive here and here, right? So if this is 1 and then this is 2, this is pi over 6 and 5 pi over 6. Yeah, trig. So x is pi over 6 and 5 pi over 6. And so then I need to make my statement. I'll squish it in down here on the bottom. F has a horizontal tangent at, I'm going to run out of room. I'm just going to go to another page. X is equal to pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6. And those would answer all of the questions that you had in that particular problem. All right, my dears, that's it for today. I will see you soon.